we
Good
have
evening, sir.
good evening, good evening. So in last class, what we have seen the all property of free particle, and we have also tried to see that how that we can understand the step potential. So let's go for the next level of step potential. And so in the last class, we have one type of potential. This is your step potential. Obviously, this is origin O. Let's say this is positive X, and this is basically potential V naught. And we are talking about particle who has energy E, and E is greater than V naught. So we have two reason. So this is reason 1 and this one is reason 2. So we have solve the Schrodinger wave equation into reason 1 and reason 2. So for reason 1, we got the value A e to the power I kx or k1x plus b e to the power minus I k1x. And similarly, you can just go for psi 2 is equal to c e to the power I k2x. And you remember that we have taken that d is equal to 0, where the value k1 is equal to root under 2me upon h cut square, and k2 is equal to all about 2m e minus v naught h cut square. So these are the thing we have done into last class. So and we have also identified that this is incident wave, this is reflected wave, and this one is transmitted wave. So I can identify psi incident is equal to a e to the power I k1x, and psi reflected is basically b e to the power minus I k1x, and then psi transmitted is equal to c e to the power I k2x. We just want to find how much current is associated to psi incident, psi reflected, and psi transmitted. So obviously, we can use the current formula, and we can directly write that the current associated with this particular psi 1 is equal to h cut k1 upon m mod a square. Remember, this is the thing we have done in the last class, how we can get the current density. This is momentum into amplitude square or probability density. Similarly, we can also define psi reflected, and this will be minus h cut k1 upon m mod b square, and here this will be h cut k2 upon m mod c square. So you remember we have used the formula of jx, and just we are doing this particular thing. So you can write this is equivalent to j incident, this is equivalent to j reflected, this is equivalent to j transmitted. Now let us try to define two new parameter. The first parameter is all about reflection coefficient. What is reflection coefficient? Is jr upon ji, and we have to take the mod value, and because this is just a number, and we just want to see how that incident intensity and reflective intensity will vary to each other. So we have just taken that ratio between that what is the reflector, what is coming, and after it is going to interact with this particular potential, what is going to happen. So with respect to incoming wave, or uh, the intensity associated with that wave, intensity means just I am talking about current density. This is all dependent on this particular current density. So JR upon JI, hence this term will cancel out. We have mod B square upon mod A square. And similarly, we can find the transmission coefficient, and that will be JT upon JI, and we can take the mod value, and this value is equal to, you can find mod C square upon mod A square, and here K2 upon K1. And now what we have to do, we have to just find these ratio, whether this ratio have some meaning or not. And obviously in classical mechanics, this ratio R must be 0, because if particle has greater energy than V naught, then particle have to cross. So, but in quantum mechanics, we will see it has some different significance. So up to that, if you have any doubt, you can just ask me. Otherwise, I will go for next level of calculation. Okay. So let's go for next level of calculation. What we have to do? So solution of Schrodinger wave equation must be always continuous as well as differentiable. Obviously, you know, this is the also property of second order differential equation. But here at x is equal to 0, the right hand function and the left hand function or function related to first part and second part must be continuous as well as differentiable. So what we are going to use, we are just going to use these two condition, and we will just try to find out this ratio in term of k1 and k2, or in term of energy. We can easily find this ratio. So let's try to figure it out how we can get this ratio. So psi1 at x is equal to 0 must be equal to psi2 at x is equal to 0. So it will give us a plus b is equal to c. And second thing, what we are going to do, we will just differentiate d psi 1 upon dx at x is equal to 0 must be d psi 2 upon dx. This will be upon dx at x is equal to 0. So first we have to differentiate, and then we will put the value. Then what I will get? I will get I k as common. And what is this? A minus b is equal to I, this is k1, I k2 c. Because just we will differentiate it, ik will come outside, and this will become it minus, and x is equal to 0, then this will be something ik minus b. And second hand side, you have ik2 c. And this is obviously k1. So we have two equation 1 and equation 2. But so is that this is visible to you?
Yes, sir.
No, sir.
No, sir.
Okay. If there is some problem, just you can use from here. Now it's okay. Same thing I have written here. Okay. Now what I have to do, I have to solve these two equation. But solving these two equation means what we have to find? We have to find that ratio b upon a and ratio c upon a. So how we will solve it? So first equation is a plus b is equal to c, and second equation is a minus b is equal to k2 upon k1 c. So what you will do? You will add it, then you will get c by a. So when you will add it, then you will get 2a is equal to 1 plus k2 upon k1 into c. And from here, we can get the value c by a. So from here, you can easily get the value c by a is equal to 2k1 upon k1 plus k2. So now from here you will put the value of C in term of A here. You can get the B by A from this equation. You can just easily put the value C is equal to 2k1, k1 plus k2 in this equation. You can get B by A. And from here, I can write the value of B by A also. So when you will get it, you can solve it easily. So we can get the value B by A as k1 minus k2 upon k1 plus k2. This is very simple class 6 or 7 type algebra. You can just do it. I am interested into this part. So this term can be written as k1 minus k2 whole square by k1 plus k2 whole square. And here you will just take the square, then k1 square, but this k1 square will cancel with this k1 square, and that will remain 4. So that will be 4 k1 k2 upon k1 plus k2 whole square. So if you have any doubt up to this, you can just ask me. Otherwise, I have to erase this thing and I have to analyze all this thing. Calculation is straightforward, nothing to do such hi-fi, any type of hi-fi equation or something else. Okay, so let's try to analyze all this term. If we have reflection, and this is known as reflection coefficient and this is known as transmission coefficient. So let's try to write the exact thing, and what we want to analyze. This is pretty interesting, and how we can explain this thing is more interesting than anything else. Now, the reflection coefficient R is nothing k1 minus k2. I can put the value of k1, so you can get the value E minus root under E minus V naught upon root under E plus E minus V naught. I can put the value of k1 and k2. So this is reflection coefficient. And if you can add it here, suppose R plus T, if you will add it, then k1 minus k2 whole square plus 4k1 k2 will be just tell you about the k1 plus k2 whole square. So this will be exactly k1 plus k2 upon k1 plus k2 whole square, and that will be 1. So if we can get the reflection coefficient, the transmission coefficient is 1 minus r, or you can easily find from here also. But I uh, am used to use this particular formula. Now look at the analysis part. This is very interesting. What is going to happen quantum mechanically? And this observation can be justified by this particular thing. Now suppose energy is very greater than V naught. What will happen? Suppose energy is very greater than V naught, then
V naught
you have,
can be
so if E is very greater than V naught, then V naught is not significant, and R is equal to what? 0. Means there is not any chance that particle will come back. And suppose in second case, I have taken E is equal to 2 times V naught. Let's say E is equal to 2 V naught. Then what is reflection coefficient? You can easily calculate. The reflection coefficient is 2 V naught minus V naught upon root under 2 V naught plus V naught. And now if you can, root V naught will cancel out. So you have 1.414 minus 1, and you have to take the square, 1.414 plus 1. And if you will take this square, you will get reflection coefficient is all about, I have calculated with myself, this is all about 3%. This is all about 3%. 3% means 3 upon 100. Okay. And now I have also calculated one more number, and that is for E is equal to, basically, this is a second number. E is equal to, I have taken 1.01 V naught. So it is just near about this particular potential. So what will happen? E is equal to 1.01 V naught. What you can see, you can find the reflection coefficient is about to 67%. How we can explain this thing? So I have taken all this number, and you can just tell me how we can explain all this kind of situation. If E is very, very greater than V naught, suppose it is 100 times V naught, then reflection coefficient is not exactly 0, but near about 0. You can neglect that thing. But here you can have 3%. What is meaning of 3%? Means if you are sending 100 particle from left, out of this 100 particle, 3 particle is coming back. 3 particle can come back, and 97 particle can just transmit. And if I will take the energy 1.01 V naught, means it is near about this particular V naught, then 67 particle is coming back. My goodness. If I am sending 100 particle and I am throwing 100 particle, and every particle is identical, don't worry. Every particle is identical. Even if they are identical, the initial condition are same, but they are not following the same trajectory. And this is basically our observation. And this observation can be explained by this particular mathematics. So what we have seen? We have seen even if our energy is greater than V naught, the particle can reflect back. And this is a basically quantum mechanical phenomena. This cannot be explained by classical mechanics. So my energy is greater than V naught, the particle can reflect back. How we can explain this thing? This is very interesting. How we can explain this thing? Obviously, these are the number and these are the observation. It's okay, observation and my calculation match. But how we can explain this thing? Can anybody suggest me some explanation?
Sir, tunneling effect.
No, टनलिंग कहाँ हो रहा है? There is not tunneling. मतलब स्टेप पोटेंशियल देखते हो, टनलिंग कर देते हो ना? अपनी पुरानी चीज को भूल जाओ, है ना?
Quantum mechanics, we take average.
Yes, then what will happen?
Sir,
Okay, good, very good, very good. Yes.
तो सर एवरेज एनर्जी में सर तो कुछ पार्टिकल, मतलब अगर सारे का एवरेज जोड़ा जाएगा सर, तो
नहीं सारे का एवरेज तो नहीं जोड़ा जाता ना. एवरेज तो होता है, एवरेज इज अ नंबर.
एवरेज. यस सर. तो सर एवरेज में सर कुछ पार्टिकल सर जो है उसको क्रॉस कर जाएंगे उसको.
नहीं आप,
और 67% पार्टिकल जो
नहीं ऐसे नहीं. ठीक है, आप समझने की बेटर कोशिश.
हाई एनर्जी.
How some particle have high energy? I have given the energy E.
Because we taken only average energy in this case, but in average energy case, some particle have higher energy than this V naught, so those particle can pass.
Good. Very good. Look at, I am just giving you analogy. Analogy is very simple. Suppose I have taken an exam, and in this examination, what will happen? The average marks is, let's say, 30. Average marks is 30. And I have making a 25 marks as a cutoff. Then even if average marks is more than 25 marks, it is not necessary that every student will pass, isn't it? Maybe some student can get the marks 20. Then he cannot cross the barrier. Even if the class average is basically 30. And this is your cutoff. So, what is E? E is our classical energy. E is our classical energy. And this classical energy in a quantum mechanics can be treated as an average energy. And that average energy, so if my average energy is E, there may be chance that particle can have more than energy V naught or less than energy V naught. There are fair chance. So those particle whose energy can be less than, or whose energy can be actually less than V naught, they can reflect back. Similarly, I have taken the average marks of the class is 30 and cutoff frequency is 25. In spite of that, average marks is more than cutoff frequency, cutoff marks, then it is not necessary that every particle will cross. So why you are saying that as our energy is near about the potential, then chance of reflection is more. Why? Because this energy can be between average energy minus delta E and average energy plus delta E. So you can just use this expression. So what can be there? Just I am writing it nicely. So what can be there? That average energy minus delta E, and this is particle of energy of particle, and this is average energy plus delta E. So what will happen when your energy, and this is the possible value of energy. Okay, so there may be chance that this number can be less than V naught, and when this number will be less than V naught, then obviously particle have to reflect back. And this thing easily can be understood by the uncertainty principle. So whatever we are seeing here, E is the average energy, because we don't know that our particle are in which state. The particle can have superimposition of n number of state who will give the average energy E. You can have n number of superposition of a state which has average energy E. In that superposition state, there may be any state can have energy which will be less than V naught. And once its energy is less than V naught, it will reflect back. Otherwise, it will cross. So philosophically, from the uncertainty principle, we can understand this particular phenomena. And this is all about the purely quantum mechanical phenomena. This cannot be explained by the classical phenomena. If you have any doubt, you can ask me. Otherwise, I will go for energy less than V naught. Here I am talking energy of particle means energy of any state. Means energy of any state. I am talking this thing. Energy of any state. This will be that you can use this thing. Okay, so let's go for straightforward for E is less than 0, and this is also very interesting. So let's try to go for this. So in this case, suppose this is my again potential is V naught and particle is coming from left. What will happen? Classically, the particle will collide it and come back. It will collide and come back. So classically, this can be happen. But let's see what will happen quantum mechanically. So again, we have to solve the Schrodinger wave equation into region 1 and region 2. Region 1 is again same thing. So I will just write and this is the value of energy. And this energy is basically less than V naught and greater than 0. So this is my energy. I can write directly psi 1. Psi 1 is equal to A e to the power I k1x plus B e to the power minus I k1x. I have to solve the Schrodinger wave wave equation into region 2, and this will be minus h cut square d square psi 2 upon dx square upon 2m. Here is the potential psi 2 is equal to E psi 2. Now, this equation can be written d square psi 2 upon dx square plus, you can write 2m E minus V naught h cut square psi 2 must be equal to 0. You have to keep in mind that E is less than V naught. So I have to make this equation as positive. So what I will do, I will write V naught minus E and I will take this thing as negative. So the equation can be written as d square psi 2 upon dx square minus 2m V naught minus E upon h cut square psi 2 must be equal to 0. And so I can write this equation as d square psi 2 dx square. I will put gamma, this is psi 2 square is equal to 0. What is gamma? Gamma is nothing but root under 2m V naught minus E upon h cut square. So you have done your differential equation. So what should be the solution? The solution will be psi 2 is equal to, let's say, c to the power minus gamma x plus d to the power gamma x. And yes, if wave function goes to infinity, then it must be decay. It must be decay. So as x tends to infinity, what will happen? Psi 2, this will be go to 0, but this will blows up. This will go to infinity. So why x tends to infinity, the psi 2 must be go to 0, which implies d must be 0. Different reason here. In the last problem, we have talked about the different reason. Here we have different reason. Here is the mathematics. Because if this will be go to infinity, this is not any sense. So it have to go to basically 0. Then it will go to 0 only if d is equal to 0. So what will be psi 2? The psi 2 is equal to c e to the power minus gamma x. Isn't it? Now, can you tell me what will be current associated to this one?
0.
0.
Yes.
So current associated this one is 0. So there is not any current. But even if this current is 0, there is probability density. What is probability density? This is mod c square e to the power minus 2 gamma x. And now you can find, so current into this side is 0. So I can write current with the transmitted wave is 0, which means reflected wave have current have, so transmitted wave is 0 means transmission coefficient is 0, because if transmitted wave has current 0 means transmission coefficient is 0. If transmission coefficient is 0 means reflection coefficient will 1, because we know that must be r plus t must be equal to 1. Now the same thing we expected also. Same thing we expected. In classical mechanics, what will happen? The particle will go there and it will collide back. There is not any chance that particle will come into this region. But even if you can see the reflection coefficient is 1, transmission coefficient is 0, even if it is there, if we will plot the wave function into two region, and in this region, you remember the last class that we have a e to the power ikx plus b e to the power minus ikx. If you will calculate the mod psi square, you will get mod a square, mod b square. Remember psi star psi? You can easily find. What will be psi star? Psi star is a star e to the power minus ikx plus b star e to the power I kx, and then you can easily find mod psi square. And once you will find the mod psi square, you can get mod psi square is proportional to cos 2kx. You can easily find this particular thing. So, and we have done it into last class also. So what will be wave function here? The probability density in this region is something like this. But in second region, there is some decaying part. So what we have seen? We have seen even if reflection coefficient is 1, transmission coefficient is 0, there is finite probability that particle will find into classical forbidden region. This is the most exciting thing. This is classical forbidden region because energy is less than V naught. So kinetic energy is negative. So classically you cannot terminate the particle into this region. But even if this reflection coefficient is 0, sorry, reflection coefficient is 1, transmission coefficient is 0, you can find the particle can tunnel down. And this is all about quantum mechanical effect. And again, you can understand this thing with this particular average and uncertainty principle. And same logic I am talking about. Suppose the cutoff marks is 45. The cutoff marks is 45, and we have, this is your cutoff marks, means the particle will cross when you have 45, and average marks is, even if let's say 30, this is your average value, and this is the cutoff value. You cannot give the guarantee that all people will fail. Some people can get the more marks to 45, then he will tunnel down. So similarly, what can happen? Similarly, we can write that our energy of state, again my energy of state or energy of particle, can be between E minus delta E, and this is average value, and this will be E plus delta E. So there may be chance E plus delta E will be greater than V naught. There may be fair chance that expectation value of E plus delta E, this EP can be in this range, and this can be greater than V naught, then it will be cross it. Now, this beautiful process is known as tunneling effect. So this is known as tunneling effect. So what is tunneling effect? Tunneling effect is, you can just write down all this. So even if E is less than V naught, reflection coefficient is 1, transmission coefficient is 0, there is finite probability that particle can tunnel down in classical forbidden region. So you can just find that, and this effect is known as tunneling effect. This is known as tunneling effect. So this is the thing. Now, suppose I will send an electron as well as proton with same energy. Then which one is the for the electron and which one is for proton? This is first one and this is second one. Can anybody tell me? Which one is the for electron and which one for the proton?
First one electron, sir.
First is a proton.
First is a proton.
So first
Very
proton,
good.
second
Very
electron.
good. How you can say? How you can say? You can just write this mod
So
size.
proton is proton.
हाँ बता रहे हैं. Okay, good. So this is mod c square e to the power 2 gamma x, and this is mod c square e to the power minus 2, and this will be 2m v naught minus e upon h cut square x. Now, if mass is heavier, then mod psi square will decay faster. If mass is heavier, then mod psi square decay faster. So obviously, this is for proton and this is for electron. So why for the classical particle, the mass is very heavy, so it will tunnel down in this region only. Suppose I will take a marble ball. The marble ball have very heavy mass than proton. It is something like infinite mass of the proton. Then what will happen? It will just decay here. It will not go into this region only. So why this particular observation is more significant for the microscopic particle, such as electron, proton, this kind of situation. And now I am just taking this particular limit. If V naught tends to infinity, then what will happen? If V naught tends to infinity, then what is going to happen?
So psi will be 0.
Psi will be 0. So mod psi square will be 0, means psi will be 0. Means whenever your potential is infinite, your wave function must be 0. So you can remember this particular thing. So when potential is infinite, psi tends to 0. Psi will be 0, 100%, and not tends to 0. That will be 0. That equal to 0. So now we will use this stuff and we will go for the next level of free. Everything is free particle. So at this level, I am not going to separate it. This is step potential. This is particle in box. Everything is free particle. So if one question will come, they will come from the free particle. Either they will come from a step potential, or they will come from the without a step potential free particle, without any change in potential. Now we are going to discuss a very extraordinary system, and that is the actual system, and this will be particle in infinite box. So this is the part of also free particle. But what will happen? The particle will be trapped inside this particular region. So in some region it is going to trapped. So let's try to go for that. But before that, if you have any doubt, you can just ask me.
सर इसमें d equals to 0 के केस क्लियर नहीं हुआ.
D is equal to 0 का केस क्लियर नहीं हुआ, क्यों? Because it is nature of Schrodinger wave equation that if you will go to infinity, x tends to infinity, then psi cannot be go to infinity. If psi will go to infinity, then what will happen? You can never normalize it. You will never make it a square integrable, isn't it? So इसके कारण हमें ऐसा psi लेना पड़ेगा जो कि infinity x की वैल्यू बढ़ने से, if you will increase the value of x, psi must be decrease. So why? Suppose you have taken this psi 2 is equal to a e to the power minus gamma x plus, sorry, c e to the power minus gamma x d e to the power gamma x. When x tends to infinity, what will happen? This will go to infinite and this will go to 0. So this is automatically going to 0, means it is acceptable. But this is going to infinite. This psi tends to infinite or psi is equal to infinite is never accepted, isn't it? So why there is only one choice, that I can fix d is equal to 0. It is not about mathematical solution. It is all about the solution which can be accepted to discuss our physics. So if I will put the d in this region, then it will create a problem. So why I have kept this thing as 0. Are you getting this thing?
Yes, sir.
Okay. So let's come to a very famous topic, that will be particle in box and particle in infinite box. So we will solve two type of box. Today I will solve for 0 to a, and tomorrow I will solve for minus a by 2 to plus a by 2. Then we will discuss and analyze each and everything. Calculation is very simple, meaning how we can explain all this thing. So let's try to go for it. So we will just go for particle in infinite box. So what is infinite box? So you can write Vx is equal to 0. X is between 0 to a, infinity otherwise. Means I am talking about this type of situation. This is 0, this is a, and this is infinity. So inside this box is free. Inside the box, the particle is free. So classically, what will happen? Classically, you have any value of momentum and any value of energy, and you have only kinetic energy. So what will be the classical Hamiltonian? This will be something px square upon 2m. And obviously, your particle is confined inside this box. And you can have any value of energy. Your energy, so classically, your energy can be between 0 to any value of energy. You have any value of energy. And if I will ask you what should be the minimum value of energy, you can, whatever the energy you can think greater than 0, that is the minimum value of energy classically you can achieve. Means I can achieve the value of delta E where delta E tends to 0. Because I cannot make the particle stationary. The stationary particle is not there. So why I am not writing this will equal to 0. It should be greater than 0, but it can be any value. So classically, what will happen? Classically, you have infinite number of energy can be possible. If I will ask you, what will be energy between how many number of energy or how many number of state between E to E plus dE? Then what should we answer? How many levels are there? How many energy levels can be there? Infinite
Infinite.
number of energy levels can be there. Classical mechanics, you can have any value of energy. But what will happen quantum mechanically? This is very exciting. So obviously we have to solve the Schrodinger wave equation. This is reason 1, reason 2, reason 3. What will be Schrodinger wave equation into reason 1? Can anybody tell me directly? 0. अभी तुरंत तो किया था. जहां potential infinite होगा, that will be 0. Because potential is infinite. In this all region, you have infinite potential, okay? In this all region, you have infinite potential. Means you cannot cross it. So when potential is infinite, but psi is 0. What will be psi 2? Psi 2 is all about free particle. A to the power ikx plus b to the power minus ikx. You can put the potential 0 and you can get this value. Can anybody tell me what is value of k? Root under 2me upon h cut square. What about psi 3?
0.
0.
0.
Everything is correlated. जो पहले किया है उसको आपको यूज करना पड़ेगा. I am not expending unnecessary solving the Schrodinger wave equation again and again. Okay, we have to focus on the main concept. Now, this is at x is less than 0. This is x is greater than a, and this is all about x is between 0 to a. Why I am taking this equality sign both side?
Wave function
Can
should
anybody
be,
tell me?
wave function
Because
should,
equation should be continuous. The wave function must be continuous, and I have to define my wave function from minus infinity to plus infinity. Isn't it? So, wave function must be continuous. Psi 1 at x is equal to 0 must be psi 2 at x is equal to 0. So, from here, you can have 0 is equal to a plus b. And from there, I can easily write b is equal to minus a, or a is equal to minus b. So what should be psi 2? So psi 2 can be written as something a e to the power ikx plus, sorry, minus. This will be minus e to the power minus ikx, isn't it? This is your psi 2. What should be momentum associated to this particle?
H cut K 0
Sir,
होना
plus
चाहिए
minus H cut K.
Plus minus h
average.
cut k. Either you will get h cut k or you will get minus h cut k.
Minus H cut.
Zero is the average value of energy. Sorry, average value of momentum. क्योंकि जितनी momentum जाएगी उतनी ही momentum वापस आएगी. Then average value of momentum is zero. So please, you have to keep in mind this is the eigenfunction of momentum. And now, so I can write this equation as something c sine kx, isn't it? This is the equation of c sine kx. Okay. Next, we have to just go for psi 2 at x is equal to a must be equal to psi 3 at x is equal to a. And from here, you can write c sine ka must be equal to 0. And from there, we have a very interesting observation. This will give you very interesting result. For c sine ka is equal to 0, which means c cannot be 0 because c is equal to 0, then wave function is 0. So I cannot allow c is equal to 0. So what will happen? Ka must be equal to n pi. But if n is equal to 0, but sorry, k is equal to n pi, but we don't want k must be equal to 0. So why I can claim the value of n can be equal to 1, 2, 3, and so on. The value of n can be 1, 2, 3, and so on. Because if I will take n is equal to 0, then which means this k must be also equal to 0. And when k is equal to 0, this will be again 0. The whole function is 0. So c is not equal to 0. K also must be not equal to 0. And that will give you this particular thing. And now look at here. In the first time, you can see that wave vector is going to quantized. Wave vector is going to quantized means what? Your momentum. Your momentum, the value of momentum px is h cut a, and that value is n pi h cut upon a. So this is the momentum. And what are the possible momentum? If I am just talking about the magnitude, but if you will take the momentum value, so possible momentum px can be plus n pi h cut upon a as well as minus n pi h cut upon a. So you can find this momentum can be quantized. You can just easily find this momentum. What are possible value of momentum? Because mod px is equal to this one. So px can be minus n pi h cut upon a, and px can be plus n pi h cut upon a. And if momentum is this one, and you know for the free particle, this total energy is nothing but the kinetic energy. And what is your kinetic energy? Your kinetic energy is, or total energy E is nothing but the kinetic energy, and this is px square upon 2m. So either you will take plus momentum or negative momentum. What you will get? You will get the energy is n square h cut square n square pi square h cut square upon 2ma square. So this is your energy, and you can see energy is fully quantized. Suppose this is energy, how much momentum is associated with this? Can anybody tell me? If this is energy, how much momentum is associated with this?
H cut K.
Sir, n pi
No,
h
this one.
pi h
H
cut
cut
pi
upon a
h
or
cut
minus
pi.
n pi h cut upon a. Both will give you same energy. Isn't it? So, and now we can just go to normalize this function. So up to this, if you have any doubt, you can just ask me. Then we will just go for normalization and we will write the final equation.
Sir,
Mhm.
sir, why can't we choose n as 0?
Because if you will choose n is equal to 0, then Ka in this particular Ka, this K will be equal to 0. Isn't it?
So then sine 0 is 0. Okay, k is 0. So
Oh,
yeah.
okay. K is
Momentum
equal to
is
0, then whole
yeah.
thing is 0. Then
Yeah, yeah,
this all term is going to 0.
yeah. Fine.
We want some finite value, na?
Yes, sir.
We want K is equal to n pi, but we don't want K is equal to 0. What we want sine K is equal to 0. But same time, I don't want K is equal to also 0. Okay?
Yes, sir.
Okay. So why we are talking this thing? So now we are going to normalize this particular thing. So normalization, because it is bounded, so you can easily normalize it. So what will happen? This mod psi square dx from minus infinity to plus infinity must be equal to 1. But obviously my all wave functions are 0 outside potential. So 0 to a mod c square sine square. And now I can put the value of nk. So you can put the value of kx. So I can put the value of k is equal to n pi x upon a dx is equal to 1. So what I can get, how you will integrate it? Can anybody tell me how you will integrate it?
So
Just
science
you
square.
will open it cos 1 minus cos 2 n pi x upon a, and you can easily integrate it. You can get the value of mod c is equal to root under 2 upon a. You can easily integrate with this formula. Okay, cos 2 n pi x is equal to cos square n pi x. Sorry, you can use this formula sine square n pi x upon a is equal to 1 minus cos 2n pi x upon a and half. Okay, and now you can easily integrate it. So it's a very simple stuff. So this is your normalization constant. So what I can get? So I can get a very interesting result, and that can be written as in term of kit also, because we have normalized and we can write each and everything. So we can write h phi n is equal to n square e naught phi n. You can find h phi n is equal to n square e naught phi n. What is phi n? Phi n is equal to root under 2 upon a sine n pi x upon a between x is between 0 to a and 0 otherwise. And what is your En? Your En can be written as n square E naught, where n is equal to 1, 2, 3, and so on. And what is value of E naught? E naught is pi square h cut square upon 2m a square. So this is some constant. So what you can find? You can find that energy is now not continuous. Energy is discrete. So if you want to go for schematic diagram of different levels, you can easily find the minimum value of energy is fixed, E naught. The next level of energy is nothing but 4 E naught. And then you can go for 9 E naught, 25 E naught, and so on. So this is the all story. This is the half part of particle in a box. I will go into next part into tomorrow's class. that will again, we will use the same potential, but now we will shift it towards left, and then we will try to figure it out how parity will be come into picture, and then we will try to solve different types of problem. Okay, is that any doubt? You can just ask me. If you have any doubt, you can just ask me. Okay, just revise it. So tomorrow, first I will take your doubt, then I will proceed ahead. Okay.
Thank you, sir.
Thank you, sir.
Okay. Okay.
Thank you.
Thank you, sir.
Thank you, sir.